Hello everyone and welcome to MATLAB tutorial brought to you by MATLAB Helper. In the previous tutorial we started discussion about optimization, and in particular we talked about golden section search method of one-dimensional optimization. Now moving further, we will first discuss parabolic interpolation method of one-dimensional optimization, and later we discuss multi-dimensional optimization. Parabolic interpolation is given by this equation where x1, x2 and x3 are the initial guesses and x4 is the value of x that corresponds to the optimum value of the parabolic fit to the guesses. We shall implement this equation using MATLAB. Consider a problem. Use the parabolic interpolation to find minimum of fx equals to x square by 10 minus 2 sine x with initial guesses of x1 is equals to 0, x2 is equals to 1 and x3 is equals to 4. This is the code for one-dimensional optimization. Here we have created a function parab x comma fx equals to parab where f is name of function, x1, x2, x3 are the initial guesses, es is the desired relative error which is by default set to 0.0001%, and the output is stored in a matrix where x is location of minimum and fx is minimum function value. Let us write the function. If Nagin is less than 4, it gives an error. At least 4 input arguments are required. So you have to insert minimum of 4 input arguments to get the function at work. If Nagin is less than 5, that is es is empty, we set es equals to 0.0001, which we have already discussed earlier to be the default value. Next we perform the iterations and implement the parabolic formula, and after every iteration we write iteration is equals to iteration plus 1, find the absolute value, store it in root, and x is equals to root will give us the location of this one-dimensional optimization, and fx is equals to f of x. So let us run the code. To run the code, we type in command prompt y is equals to @ of x into the bracket x square 2 by 10 minus 2 into sine of x, which was the given equation in the problem. Next, we call the function xmin, fmin is equals to parab y, 0, 1, 4. Now here we have defined only 4 input arguments, and hence the default es be 0.001%. Here is the output, gives xmin as 1.4276 and fmin as minus 1.7754. Now let us implement multi-dimensional optimization. Consider a problem. Use MATLAB's graphical capabilities to display the following function and visually estimate its minimum in the range -2 less than equal to x1 less than equal to 0 and 0 less than equal to x2 less than equal to 3 for the given equation f of x1, x2, which is this equation. Now let us see the code. Here we have implemented the code and we define z as the given equation 2 plus x minus y plus 2 and subplot this equation. Now we use the command contour and apply it for x, y, z to get a contour plot. We subplot this again. Get the minimum and maximum values of z, we use floor and cell commands. We also define attributes X label, Y label, Z label and title for both the cases. Now to get the output, in the command window, we type the given equation as f. Then we write x, fval is equals to fminsearch. We have used a function fminsearch which is available in MATLAB, which is inbuilt in MATLAB, and we need not write a separate function for it. So we press enter and get the values of x and fval. Now let us run the code to get the output figures. So this is the output for two-dimensional optimization. As displayed in the figures, both plots indicate that function has a minimum value of f x1, x2 equals to 0 to 1, located at about x1 is equals to -1 and x2 equals to 1.5. Hope you guys enjoyed the video. Don't forget to hit the like button. Also subscribe the channel for updates on more such videos. Thank you. Bye-bye.